Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back in Work Physiology tutorial with the SKI Laboratory. Before starting the tutorial, let's pray together. Praying start. Praying enough. In this tutorial, we are gonna discuss about biomechanics. And the outline of this tutorial that are objective, input and output tutorial, material, exercise and discussion, and the last is conclusion. Before starting the discussion about biomechanics, we need to watch this animation. In this animation shows a man who lifts a box. We have never expected how much the weight should be lifted. Looking at the uncomfortable lifted and lifting object from the ground can cause injury. Thus, we have to notice and estimate the work lifting weight in order to minimize the injury. The objective of this tutorial: first, we are able to understand the principle of biomechanics in lifting activities. We know the amount of load received at the time of doing the work. We are able to understand the human limitation of the workload imposed on human needs. And the last, we can give recommendation based on the result of analysis with the principle of biomechanics. Then we have to know the input and also the output in this tutorial. First, for the input, that are operator's data, lifting process video, screen capture on lifting process, body angles, body segment lengths, and for output that are force compression on lumbosacral joint or L5S1, moment and force analysis, and the last is recommendation of the work system. Now we start the material of biomechanics. What is the definition of biomechanics? Biomechanics is a branch of ergonomics that combine physics technique, anthropometry, and medical science basics such as biology and physiology with mathematical approach. It has meaning at physics relate to formula of force and moment, for anthropometry relate to body segment and length, and medical science regards feedback during the activity, especially there is some disorders, and math relate to formula to calculate force at L5S1 or lumbosacral joint. Based on Kevin and Anderson 1991, biomechanics is classified into two, that are general biomechanics and also occupational biomechanics. General biomechanics is a part of biomechanics that discuss the basic concept of human body in static or moving position. General biomechanics was divided into two terms based on Diary 1997 that are biostatic and biodynamics. Biostatics analyze the body's in static or moving position in straight line with constant speed. Then biodynamic is associated with body movement without considering the occur force or kinematic and the motion caused by force acted in the body or kinetics. Occupational biomechanics is applied biomechanics that discuss the physical interaction among workers with the machine, material, and equipment to minimize injury to the musculoskeletal system in order to increase the work productivity. After we know the classification of biomechanics, the other important thing that we have to know is mechanical analysis of action limit and maximum permissible limit. Action limit or EL is a limit for normal lifting force recommended by NIOSH. The limit for normal force is 3,500 Newton. Then for maximum permissible limits or MPL is the limit of compressive force on the segment lumbosacral joint, standardized by NIOSH. According to NIOSH, the large maximum compressive force is 6,370 Newton at L5S1. The classification of EL and MPL range is as follows. If FC less than EL, the condition is safe. If FC in between EL and MPL, the condition is be careful. If FC more than MPL, the condition is dangerous. And the analysis are if FC less than EL, the condition is acceptable. If FC in between of EL and MPL, condition administrative control approach required. If FC more than MPL, condition engineering control approach is required. Where EL equal to 3,430 Newton and MPL equal to 6,370 Newton. After obtaining the FC result, the next is classifying FC, whether it is classified as safe, be careful, or dangerous. In addition, it is also needed to give the recommendation according to the classification. If in careful condition, the necessary recommendation is administrative control. For the dangerous condition, using engineering control. Administrative control is minimizing with training and scheduling rest period that are appropriate to work. The other example of administrative control that are time of scheduling, work rotation, training, exercise, and job guarantees. Engineering control is decided to repetitive movement, irregular style, and rigid posture that can be alleviated by modified workstation, work tool, and work method. The load or object that is carried can be changed from its weight and carrying in good posture. For the example, job redesign. Enhance the work time by increasing the time spent working on the task every day, such as lifting 20 box chains to be 16 box after redesign. The lifting process of load or object relates to the operator's body distance. This relation can be seen in this illustration. The graphic illustration is divided into three areas. The lowest area is safe limit, the middle area is administrative control is required, the top area is classified the hazard category. And also being shown in that graphic is the line of EL as the limit of safe area and MPL lines as the limit of compressive force in L5S1 or lumbosacral joint. And the next is angle determination. There are several steps of drawing the angle. First, determine the point in the body segment. There are 7 body points used as following. Middle finger, on the protrusion when the hand is raised, elbow, in the crease of the elbow, back, on the protrusion when the body bending over at L5S1, and for waist, a place to put a belt, and the last is knee, the kneecap. The determination at these 7 points is because the angle formed in this body is affected when lift at the load, while the point in the knee is used as support to determine the angle of inclination. The second step is connect the point by line, like this yellow line. And the third method is make perpendicular line in every point, such as this red line. Then the last step is draw the angle between horizontal red line and yellow line, like this. And the steps for calculating the compressive force at L5S1 are: the first is calculating total force or total weight, that is accepted total force while lifting an object. The second is calculating the abdominal pressure. This pressure arises from holding the load at the time of lifting, which is influenced by the force received by the body by lifting the load. The third is calculating the muscle force. This force is resulted by movement of muscle, and the fourth step is calculating the compressive force on L5S1. Formulation used for calculating FC is on the slide, with the information that FC is compressive force, and WY total is total weight in Newton, theta 4 is strong inclination, FA is abdominal force in Newton, and FM is muscle force of spinal erector. And the first step, like the previous explanation, is calculating the total weight. This is the formulation to calculate the total weight. There are several body segments used to calculate the total weight. And the segment are palm, lower arm, upper arm, and trunk. In the calculation of object weight and body weight, gravitational force used is 9.8 meter per second square. For the calculation of weight in body segment, it is percentage in each segment multiplied the body weight. The percentage term of body weight segments are for hand or palm is 0.6% multiplied by body. For lower arm, the percentage is 1.7%. For upper arm, the percentage is 2.8%, and for trunk is 50%. After calculating the total weight, the second step is calculating the abdominal compressive force or FA. The formula of FA is PA multiplied AA, with AA, namely area of the diaphragm, has been fixed at 465 cm square. For PA or stomach pressure, with a formula like on this video, this abdominal pressure formula uses the resultant moment at L5S1. Now, to calculate the moment resultant is the next slide. Guys, in this calculation is quite a lot and relates to each other, so you have to stay concentration. The steps to calculate the resultant moment at L5S1 are: first,
the steps to calculate the resultant moment at L5S1 are: first, on the palm, calculate the MW by resultant moment on the wrist to maintain the static balance. The formula on hand palm is FGW equal with WO per 2 plus WH. Meanwhile, the moment of W is FYW multiplied by SL1 multiplied by cos theta 1. Then the second steps is in the lower arm. The result of the previous calculation, that are the force and the moment on the palm, also used in this calculation of the lower arm. FYE is obtained by adding FYW and WLA. Then ME is obtained by adding MW with other moments working on the lower arm. Similar to the previous explanation, on the upper arm also uses the previous force and moment, that are FYE and ME, as an input to the FYS and MS calculation. And the fourth is the resultant moment on trunk or L5S1. The calculation formula is the first to calculate FYT. And the formula of FYT are multiplied by FYS plus YT. The resultant moment at L5S1 is by adding up the MS and the moment working on the back. The final step in this FC calculation is calculating FM. The FM calculation formula is moment on L5S1 minus by FE point D per E, with the condition of E is equal with 0.05, and E is the moment arm length of electrospinal muscle of L5S1, and the ML5S1 is the resultant moment of L5S1. Fe is abdominal force in Newton. Meanwhile, D is the distance from the abdominal to L5S1, with the formula is on the slide. The note for the calculation of D, namely the resultant of the calculation D is in meter. To make it easier for you guys to understand, let's look at the practice question. Exercise: a worker takes a 60 kg box where his own weight is 65 kg. The distance from the wrist to the center of mass is 0.07 meter and the theta 1 is 20 degree. Distance from the wrist to the elbow is 0.28 meter and the theta 2 is 20 degree. The distance from the elbow to the shoulder is 0.3 meter with the theta 3 is 80 degree. The distance from the shoulder to L5S1 is 0.36 meter and the theta 4 is 45 degree. The abdomen inclination angle is 45 degree and the thigh inclination angle is 50 degree. Then calculate the force on L5S1 with the additional explanation is on the table. To make it easier for you guys to understand, you can pause this video and do the practice question. Then the result can be matched with the answer in this video. It will be easier to understand the concept of biomechanical. To solve the case before, there are steps similar with the explanation before. And the steps are, the first, you can calculate the W total, and then you can calculate the FYW and also MW, and the third is you can calculate the FYE and also ME, and the fourth is you can calculate the FYS and also MS. 5, you can calculate FYT and MT. 6, you can calculate FA and also PA, and the 7, you can calculate the FM and also FC. This is the result of the calculation in weight total, and the total is 991.3 Newton. And this is the calculation of segment. First, for hand segment, we can obtain the moment in the wrist is 19.99 Newton meter. For the lower arm, we obtain 101.20 Newton meter. For the upper arm segment, we get 118.02 Newton meter. From the trunk, we calculated and get the 461.1 Newton meter. For abdominal force and pressure, then the calculation of abdominal pressure, we get 0.73 Newton per centimeter square. For abdominal force, we get 339.4 Newton. Then for the calculation of muscle force and also FC or compressive force, we get for Fm in 8,475.21 Newton. For force compression, we can get 8,836.71 Newton, which the result of FC is larger than the MPL. So this MPL is categorized as dangerous. Conclusion of this activity is in the slide. This activity by the worker is categorized as the dangerous activity because the force compression or FC is above 6,370 and needs improvement in engineering control and also administrative control, so that the worker will be safe and less the risk of the injury on L5S1, so the company's target can be achieved. Okay guys, alhamdulillah, that's all the material. Thanks for you guys' attention and good luck for the report. And the last, I say wassalamualaikum warahmatullahi wabarakatuh.